So this is all about pretty much what I've been kind of working on the last 3 or 4 years. A lot of ideas from, way too much time. Realizing I suck at pen testing, and I'm kind of decent at this whole blue team crap, because I like to think I'm Batman, world's greatest detective. I can also tell that pretty much, yep, pretty much most of you never seen me talk before. I know that because you're here watching me now. It's amazing what kind of inferences you can make with a little bit of logic behind stuff. All right, where's our VGA cable gone? Let's see if this actually works first time. Stranger things have happened at sea. Of course, that's not so. Damn you, President. Changing resolutions on this thing didn't really help. So everyone kind of had this idea of what this talk was going to be about. I can guarantee you it's going to be a lot less interesting than what you imagined, because this was my title for when it got submitted to Black Hat, because Black Hat pretty much goes, do you have a cool title? And I think that's about where it ends. But there's a certain amount of truth in it. So essentially what we all do, information security, is filling the space between things. That's where the truth is hidden. For both offensive and defensive sides, it's not about what's in front of you that's actually the important stuff. It's about how you can connect it. The difference between someone absolutely green and 15-year veteran is they can see those connections between the pieces of information that aren't there in front of them. Now I have to say I can talk on this for about 30 seconds while it sits there and straight chat. I hate talking on slides, which is why I got to this one. So for most of us, we spend a great deal of our time running through tools, pulling out data and turning it into information. And the amount of that just keeps getting larger every day. Right now, the big thing is big data. Big data, small questions. So the last couple of years, I've been working on really kind of getting away from that and figuring what I think is some more fundamental problems. That scale is one of those things that we really aren't addressing. Scale isn't about how powerful your software is, how powerful the hardware is, or anything else. Scale is about how much we're actually capable of dealing with and processing. And this is the thing. We don't deal with information. We spend our time neck deep in data. So how does this end up basically coming to pass in terms of day-to-day jobs? Actually doing this for a company. We end up taking our own ability to go through things in this wonderfully non-linear fashion, make these great leaps of intuition between things, and try and do it in this wonderfully corporate process-driven method where step A leads to step B, conclusion C. What we do doesn't really work that way. So why do the systems we end up doing our jobs in try to force us into that? The real issue for us is how can we actually get together a system that allows us to be more effective in what we do? How doesn't scale? How many folks here spend a good chunk of their time training up the new guy over and over and over again? We spend a lot of time just communicating what we know down the chain of experience instead of actually applying it. So what if we could actually harness that a little better? Well, it'd be good if we actually had time to work on some of that, but it's InfoSec. Get in the morning, goalposts have changed, yet another crisis to deal with. We've spent, at least the last decade plus since things got commercially established, perpetual firefighting mode. We don't get downtime to sit around and really analyze why we do things the way we do them. Recently, I finally got some time to do that. So that's what this is all about. First thing was just, why are we still stuck like this? 2012. Everyone else gets these really kick-ass interfaces that are really designed around how their workflow works, how their brain models it. We're still sitting there running through text only, picking out the important stuff. what great software we have. We still tend to do all the work. Now, what this means is you, I, we all spend more time mucking around with data and turning it into information than actually analyzing information. And that's what we're supposed to be good at, right? We don't really do it. So within that data, yeah, that's everything we need to know. We've got to turn it into the story of your network. What actually happened here? There's the vast sea of text. Really, it all boils down to, yeah, this is what we actually saw. Whole bunch of data, but simple information. A lot of it ends up being structured. What we do isn't really that structured. Now, there's some great stuff out there. Security visualization, getting a little bit of traction. And visualization is good because it scales our ability to consume and translate more data at once. The human brain is the greatest pattern recognition engine on the planet. But most of the visualization we end up doing in our day-to-day reporting is absolutely worthless. I have a line I keep telling people, especially that they're actually developers in UX. Good visualization creates context and information that is not discernible from the raw data directly. Quick example. What is the function of a pie chart? Anyone? A pie chart is a crutch for someone who's too retarded to know what a percentage is. It creates no new information that isn't already there, especially if you just left it in text and everything. Good visualization, by finding that space between, finds things that aren't immediately discernible without large amounts of transformation and translation. They leverage the human brain's pattern recognition engine. So we're InfoSec. We like technology, kind of. We're also really bad Luddites about things. We look at something, oh, new tech, new complexity, new problems, don't want to go there. And what this ends up being is we all sit there going, I'm a command line ninja. I don't need any of that cool shit, because I can do everything command line and in plain text, which is cool. I mean, everyone should be able to do that. But keep holding on to it is the only way to actually get the truth out of stuff. We're a bunch of curmudgeons, really, aren't we? The end result, though, is we still end up spending most of our time taking all the stuff that we can see and putting into reports that other people can see. Who here really likes writing reports? You guys are weird. The end result, though, is most of the data we end up putting together ends up, because of things like SQL, CSV, tabular data, we end up getting this quantitative model of stuff. There's definite swag prize for anyone that can tell me what graph what sim this graph comes from. But this is the kind of stuff we end up sitting there looking at. We're doing security. Yeah. Find the APT in the bar chart, because the more you have of something, the worse it is, right? I mean, it's not like real intrusions, real security shit is one thing in a sea of prep. I actually came up with the term finding the haystack and the needles about this. It was going to be my book title until RSA Marketing stole it from me last year. Everyone saw my one of them. But this is the problem. We end up using these systems designed for quantitative analysis, accounting. What we do is not quantitative, it's qualitative. These 50 identical things, quantitatively, one of them is more important than the other. And it's its relationship to other things that is the quality that makes it more important. So sitting there going, we've had 150 bad login attempts on the network today. But yeah, it's Monday. Which of those bad login attempts is malicious? It's ridiculous we do this. For me, I spent years trying to build really good workflow systems using SQL, because everyone uses SQL. There's a couple of problems with SQL. It's designed for quantitative analysis. It's designed for accounting and spreadsheets and stuff where the relationships between factors are known ahead of time. My kind of rant with this is, we do security. The relationships between things, not known ahead of time. By definition, we do security. We find the relationships and interconnectedness between things discover those, bring them to light. That's what security is actually based on as far as an analytic process and everything. When you do this, unforeseen result X happens. You didn't have that in your database schema. So there's all these better ways to start looking at data and turning it a little bit more into information directly off the bat. And a lot of it comes down to, it's the relational patterns of things that are important. It's connecting the dots. That's what we do. Detectives connect the dots. There's some good stuff out there. This is Rafi Martin's Afterglow. This is just taking like raw tabular data, but compressing it down to simple relational sets. It's good stuff. And when you can see things like this and just go like, there it is, that's it, that little one, that's what I'm looking for. It's awesome. I mean, don't know how many of you guys do incident response? Everyone goes on about how pen testing is really awesome and like, yeah, I cracked it. I still get the best adrenaline rush at it. Got him, bang to the right, smoking gun right here. This is what keeps me doing this, everything. You got that one little thing that puts the rest of the puzzle together. Just like, look at this, look at this. This is it, this is proof, we got it. So, why don't the stuff we work with every day really sort of model that? Why do we spend all our time looking around with SQL queries and translating one CSV file to another, and we got all these great tools, and we spend all the time trying to go, yeah, that's mmap output, and firewall logs, and yeah, I feel really good, because I just spent this afternoon like writing a Perl script to match them all together and dump them into a SQL, and it's awesome, I got this one job done, and I'm never going to use this again. Thought we end up, because we didn't take time to define how we end up doing our work for pay in the enterprise, is we end up letting the enterprise dictate to us what our workflow should look like. And the enterprise goes, well, this kind of sounds like tech support. Tell you what, let's set up a ticket system, and we'll just create a ticket for every alarm, and then we'll get a bunch of people fresh out of college, and we just have them there, and we sit them, get them to look at the alarm and go, that's probably false positive, okay, closed, next. Does anyone ever go back and look at their historical alarms and go, oh, I wonder if this one looks like this? Maybe yesterday, maybe a week. 3, 4 months. Again, I'm going to have to drink a lot, so I'm going to say APT again. Does anyone go back and go, hey, can I figure out something like this from 6 months ago that might be some little APT intrusion that's been sitting there? God, I'm going to be so plowed in about an hour after I'm done with this talk. People sit around and wait for a while. It's not one attack, one signature. We spend all our time running around, getting information from the actual companies we work for, because no company can manage to keep all the information about itself in one place. I think pretty much every incident response team I've ever been part of ends up building their own asset management system, because they're tired of looking into 5 different asset management systems the enterprise uses that are all slightly out of date depending on which department they don't care about. Ticket systems. So then we sit around and we wonder why we can't actually scale anything to the level where we can be as, I'm going to say it, agile as our attackers. Because we end up having 8 people monitoring a company with 500 offices and 82 nations, and you just can't know everything. You certainly can't find it all the time. At least that was my team. So all us poor bastards that have been doing it for a while spend all our time not doing actual work, but holding the hands of the new guys going, oh that really obscure system over there with the hostname pattern you've never seen before. Yeah, I remember that from like 8 years ago. It does this. I think the guy that runs that stuff doesn't work there anymore. I'm not sure. We spend all our time digging up information about the companies we work for more than anything else. And then trying to just get data to work together. So, how do we fix some of this? Well, the first thing I wanted to fix was this ridiculous linear model. What we do is not tech support. It's not fix a problem, move on, throw it away, never come back to it. It's all about how's the big picture come together. What we do is connect the dots. So why are we sitting there working off these linear tech support, go fix this, next one, everything else? Things are connected. Let's look at those interconnections. Which of that line of events actually talk about the same thing? I don't know. Which of them might be the same attack? I don't know. Which one should I go next to? Well, the next one on the list, which is on a completely different system, with a completely different network, with a whole bunch of challenges. So everything I just did, working to figure out what the hell I'm looking at the first one, I then throw out of my brain to go do the next one. Which is why, on average, it seems the average incident response team, as far as managed centers, analyst gets through about 20, 25 alerts per day, and that's considered like really high throughput, which is kind of damn. But what if we just went, hey look, this other event is kind of related to it. All the stuff you just spent 30 minutes putting into your brain is probably still useful. So before you move on to something completely different, why don't we try and make sure we leave no stone unturned on what you were looking at first? Holy crap, you can actually do something that takes advantage of the way the human brain works or does not. You're probably going to find something a lot easier to identify in that set. So, Timmy has a talk called Zombie Workflows about all these horrible workflow systems we have to do to get our job done. The things that take us out of the mindset we're actually in, the mindset that is doing our job, to go and fill out tickets, timesheets, go into stuff in a knowledge-based wiki. Zombie workflows, things that break the concentration path. Everyone knows this. Like, the more you have to change context, the less productive you are. So why don't we actually have shit that resembles that? Why does every vendor want you to do your job in their product? I really like your intrusion detection system. I don't want to do my job in it. I want to use it as an intrusion detection system. Everyone has to have one. Well, put the little ticket system in here and write what you did. Like, I do not want to record my work in your product. Just want to use it. I believe the talk before me was security metrics. Is it kind of any wonder, like, all the security metrics we get are quantitative, not qualitative? Hey, look, we've blocked 4 billion spam emails. That's great. Are there more, less? What's the coefficient on this? It's ridiculous. So rather than spending our time filling out paperwork and describing what we did instead of doing it, because the systems we work with don't describe what we actually do. So the last couple of years, I've been working on incident response workflow systems, data gathering, intelligence, even trying to bridge a gap to the elephant in the room, governance, risk, compliance. Okay, I'm up to about 8 drinks after this talk, so just keep track. When I started over at Involves, they gave me kind of scope to go, okay, build a better system from ground up. And I started back on from the way I looked at, and sat down figuring out my database schema. And then kind of realized, this is exactly the opposite of what I wanted to do. I've been trying to build systems that let the analyst decide what is correct at all times. I mean, my general mantra for anything incident response has always been, the analyst is always correct. So I wanted systems that let them do it however they saw fit. And then I realized, sitting down writing a database schema, I'm sitting here trying to predict all the interdependencies between things, all the various factors that can link one thing to another. I'm not smart enough to know what they all are, and it would be really presumptuous of me to assume that everything I can think of is everything that everyone else wants. Actually, that would just make me a security product vendor, but I do work for one now. And it got to the point where I just realized that RDBMS itself, SQL, was kind of the problem. It was designed for systems where you know the relationships ahead of time. So I ended up looking for other alternatives, something that would let these relationships emerge over time. There's a couple of other options. Started looking at this thing called the semantic web. The semantic web is one of those things that has been around the corner since Berners-Lee came up with it in the first place. It's wonderfully highfalutin and academic and wonderful and beautiful and pure, and no one doing any actual real work uses it. I did actually find a couple of people that are using it in the real world really effectively, but we'll get to that in a bit. But the great thing about the semantic web is that it is all about the relationships between stuff. It's not about adding up how many of this happened or how many of this are in this category. It's about looking at relationships, interlinking between things. that space between that we exist in. The great thing about the semantic web is it's stupidly easy. I like stupidly easy. Most shit is too complicated for me to understand. If it's just complicated enough for me to understand, then I'm probably by definition too stupid to actually fix it when it goes wrong. Semantic web is really easy. Subject, predicate, object, the triple. So a really simple idea, this is a table with 3 columns. And just as you all learned in high school grammar, subject, predicate, object. Thing A has relationship to thing B. Thing A does something to thing B. This is really easy, because you can actually start defining incredibly complicated relationship sets, really vast and interwoven data sets, just from this idea of thing A, some relationship to thing B. You can just have billions of these rows. You can get some amazingly fun stuff out of it. But the really great thing about this is that that predicate is the relationship between things. When you write SQL, if you hand someone a SQL database, they might be able to kind of like reverse engineer it and pull some good queries out of it, but outer joins, cross-reference foreign keys, don't describe why those two things are related or how to use that relationship. You might have a couple of stored procedures in there that are probably named something ridiculously obscure, but mostly it's trying to reverse engineer and translate, extract, transform, and load other people's data. I am really sick of being a data transformation monkey. I wanted to be an information security guy. This, oh look, it's a schema that's actually full of information. The relationships actually get defined within the same table. We'll get to that in a bit though. 3 columns. Thing A has relationship to thing B. But once it starts scaling out, you can start seeing patterns. Just right there, Human Pattern Recognition Engine 1.0. That takes some pretty funky-ass SQL to do otherwise. That these are quantities of qualitative relationships. So who actually uses this shit? It's not just a ridiculous academic pie-in-the-sky thing that's not going to happen. Open Graph, Facebook. This is Node Graph. Node graphs are enabled by triples. Google's got on the bandwagon now and started doing their own knowledge graph thing. They're actually exposing some portions of how the whole Google search engine works through this. This is why certain words produce certain hits on Google search, because they're n degrees separated from the thing you're looking for. There's this idea that these two things are related. They're conceptually similar. Bioinformatics, about the only other field I know that's really starting to get into using semantic data heavily. I'm a huge fan of bioinformatics because these guys are starting to look at a lot of the same problems we are. A lot of unstructured data, discovering relationships emerging from things. Most of bioinformatics isn't about finding new data points. We map the human genome. We've got most of the chemicals and organic compounds out there and everything. Bioinformatics is about going and finding the relationships and the interactions between these things. Everyone's seen protein folding. You know, that's a great example. Protein folding, all the data points are known. You're just moving stuff around and seeing how the relationships change the outcome. Protein folding is about calculating these things instead of going and sitting there in the lab making 10 billion different folded protein combinations. And then there is actually a security company doing this. They do fraud detection. That whole thing of, is this a fraudulent transaction? This is kind of interesting because although this isn't network or host security, it's more behavioral. It gets into that idea of, we keep coming around to that loop of, we're going to do anomalous behavioral detection and everything. At which point I'm going to stop getting into a kill chain thing about atomic behavioral computers, but we'll get to that in a bit. These guys are actually figuring out how to do decent fraud detection based on this idea of behavioral interaction and everything. They also make one of the most popular RDF stores out there and everything, triple stores. So, how do we get this actually working for security? Well, the first thing you need is this thing called an ontology, which is kind of like a schema, but it's not, because it's designed to be added onto and iterated over time. We'll get back to ontologies in a bit. Then there's this thing called resource description framework, which is wonderfully academic. Like all stuff written by brilliantly smart people, they make it so elegant that only they can understand it. It took me about a month to figure out RDF, and it's wonderful because once you understand RDF, RDF is really simple to understand because most of RDF is written in RDF. What could be easier? But the great thing about semantic stuff is that data stores are designed to work together. I can create a database of all my stuff. You can create yours. And by exchanging like a single link, we can start working through them. So how do we start putting data together in this? This is a great line. I owe Google this one. Things, not strings. How many people work in applications where IP address is a string field? Can you manipulate it as an IP address? No, because the UX guy wrote it as, oh, IP address, that's a string. It's not a number because it has dots in it, so it won't take numerically, I'll make it a string. So try and manipulate it as an IP, you're screwed. Extract data, modify it, do some ETL, dump it back in. Once again, same old, same old. So with semantic data, you start actually describing things as they actually are. If SQL is kind of procedural, semantic stuff is very object-oriented. An IP address is an IP address and has all the capabilities and interactions that it would normally. As long as you write the ontology for it. The great thing about semantic stuff other than SQL is that it's built around the idea of there is something here we do not know. You can't link to a non-existent row in SQL. They don't have those kind of foreign keys. I really like the idea of this. This sounds like security to me. There is this thing out there, a known unknown. I know it exists, and I know this thing has a relationship to it, but I don't know what it is yet. I'd like to record that, and then when I find out what it is, I can put it there. Like that. That actually works. Connecting the dots. Can't search for what you don't know. Let's see here. God damn, I hate you.
Sorry,
Razzie, screw you.
Pardon me, mute microphone, otherwise it doesn't catch it.
Yeah, hold on, I've got to get back to where we were. There we go. Razzie is a bit of a bastard sometimes. So,
Ask them if you use a microphone so they actually can give you one.
yeah, actually, okay, back to sexy voice time. At least I think so. So this is the problem. We end up working in systems that don't record all the things we know. We end up sitting there writing stuff on wikis and paper pads and the whole shebang. You can't search for what you don't remember, or what the system doesn't remember. We're knowledge workers. It's about putting the dots together, but we don't have systems that let us do that. So how about we started looking at something that lets us record the work we actually do? Remember in math class, show your work? Well, how about we actually show our work in a system so we can go back and look at it later? See this? That looks like a great breach timeline to me. I'm about to put a few of these things together with Visio, sitting there, extracting, transforming, loading data. Why don't we have systems that actually dump reports out like this? Well, because they don't track the relationship between things like this. I really like this one. I've used it so many times. But it's way too complicated to go through right now. So this is basically it. We're spending our time running around with data. We want to be working with information. Most of our systems don't give us information. They present data and expect us to come up with the information, record it, use it, make workflows out of it. As one of my bosses has said, most of the stuff we get out of security tools and the vendor offerings these days, we're really excellent at getting everything up to the alert. Look, something bad happened. But when it comes to actually what to do with that alert, we're totally reliant on people. And getting talent to scale is one of our biggest issues. Let's face it, I think we can all say that for every one of us out here in Vegas, we've probably got about 1,000 other folks out there that also do security, that we're responsible for either helping them do it a little better or cleaning up their mistakes. How do we make our lives easier and stop having to teach people the same stuff over and over again? So I started looking at, well, this is a great theory. Let's actually put some of it into action and actually make something that's information-based, not data-based. Oh, I see what I did there. So I started getting this sort of bug in my ear about, Metasploit's really cool if you're on red team. Where's Metasploit for blue team? We have to track all this crap, train it, search for it, put the big picture together. Everyone likes doing the cool, sexy red team stuff, but blue team work is kind of slow, boring, repetitive, and we spend a lot of time looking at CSV and doing wikis and everything. Where's our cool stuff? On the same time, on the pen testing end, how much time do you actually spend doing pen testing, and how much time do you spend recording, translating everything you actually did on that pen test and putting it into a big picture report? I'm stupid and lazy. I mean, I really want tools that I just do stuff and it records what I did, and then I just kind of click, I did this because, and then it spits out a report for me at the end. So there's some great stuff out there. I've been mucking around with Dradis recently and everything. They're going down the same lines. But again, just we spend all our time translating data from one store to another. Why can't we throw it all in one? Well, we think we can't because no one's smart enough to know all the stuff you want to put in there. Can't get a schema together for that. But the point to semantic stuff is, I can have my schema, you can have yours, and they can interact. How about that? So this is what I end up coming up with. And yeah, I've been working with Sims so long, I decided I had to kind of redefine it. I'm sick of point-in-time data. Information and events, we need a layer above those. But intelligence and exposures. What's actually happening? Everyone loves using the term situational awareness these days and everything, but I wanted something less government. Does that work? Also, I work for a company that puts out something called OSIM. So, hey, look, I'm running with a theme here. This is because I cannot start writing a piece of software without having an awesome name for it. So I just pretty much went for the jugular here, and what else was I going to call it? Workflow, because I ended up spending too much time being that integration guy for every incident response team I was on, and as boring as workflows are, let's face it, integrating shit is just making better workflows for people to do better work with their jobs. Most of them suck. I hope this one doesn't. There's lots of panic out there. Also a little bit of jealousy. Where is this shit in security? Where does like Facebook and all the Web 2.0 guys and everything else get the cool shit? Last time I checked, we were the people with penetration tester on our business cards. I don't know about you guys, but I got into this thing so I could look cool and get chicks. Actually pretty well. Though I've never had a business card that said penetration tester. Though my current business cards do say research operative, because that's the job title I asked for, and my boss was going, that's cool because I'm about to take chief hacking officer. Let's put it this way, the new management team comes on in a week. They don't have any say on anything until then, and then we're grandfathered in. Look at that though, wasn't that great? You know, screw it, I'm going to go back again. I'm going to go back and look at this again. I'm going to go back and look at this again. I love this. What's this? This is like, hey, this is Minority Report shit. Why don't we have that?
It's probably an analytics tool that runs on top of our so.
None of those actually are. Yeah, most of them are just straight sets. In fact, many of them are actually just CSV, but the big graph one was semantic. So this is about what I've been working on for like the last, I'd say 9 months, but the first version I built and it sank into the swamp. But I wasn't going to be distracted and disheartened, so I built a second version, and that sank into the swamp too. Then I built a third version, that one stayed up, and that's the one I'm trying to get released by the end of Q3. And yay, employer pimper cheer, Alien Vault has been awesome, and they actually kind of like leave me alone to go just kind of make this happen and make it kick ass. And they've been really cool. So there we go. There's my responsibilities for vendor pimping done. what I originally wanted to do was build a better incident response application. And I got to the point where I realized I wanted better tools to write a better incident response application with. And then it got to the point that the better tools I were looking at, I've had this mantra for years about if the solution you have in mind only fixes one problem, it's probably the wrong solution. If it doesn't accidentally fix something else as a byproduct, you're probably not looking at the root issue. So Awesome Framework ended up being that. It ended up being that, well, I'm a little behind on that incident management app, but I'm writing something that's going to allow us to write a lot better stuff than just incident management applications. I want to write better pen testing applications, better risk management applications. What I really want is for people in pen testing and risk management and incident response and the compliance team and everything to actually be able to work on the same data set so that when I'm sitting there looking at something going, what the hell is this? Why is it doing this way? This looks malicious as hell, but I know that this is like some dumb decision the employer has made. Like, I know this is a legitimate business process I'm looking at here, and somewhere there is some paperwork saying why it was done this stupidly. But the person that actually knows that probably doesn't work here, and it's not recording everything. And I just start thinking, well, you know, when he did that, and he just went, yep, I did this because, and linked a couple of things together, I could sit there and go, oh, look, it's this system, here's that risk system. That would be really cool. Like, hey, not only would we be able to like share workflow and information, we'd have to talk to each other less, especially the compliance guys. I was really hoping I was going to have something a little more ready for release here. I am terrible at predicting how long stuff's going to take, so maybe end of Q3. Security's a people problem, right? Physician, heal thyself. This whole thing was about making us better, making our jobs a little more fun, and putting a framework together that would allow us to write applications that would allow us to spend, not have us spend so much time doing data transformation and crap. There are all these great little applications out there. My dream for this is you go, hey, I just write a little awesome plugin, and then the stuff that comes out of this, I can run it, and it gets dumped into a little knowledge store that other fine folks dutifully doing their work can have access to and go, oh, that's why that is. But for me, I start out with an incident management app. I'm doing this so I hope people are going to write applications that are just way cooler than anything I could ever imagine. Maybe we'll actually bring some scientific style research into this. So this is what I'm doing with it. I'm an incident response guy. This is what I know. I've had this idea of just-in-time incident response for ages. I don't need to look at every single alert that comes off the systems. I need to look at the alerts that are actually bad shit happening. Well, right now we can't do that until you look at every single one of them. And hey, look, there's a queue of 3,000 alerts here, and all first 2,000 of them are all critical. Some criticals are more critical than other criticals. So you don't have to look at everything. You don't have to do all the work. If you look at the stuff that's actually dangerous and ignore the rest of it, you're fine. You can clock off for the day. I don't need to look at the rest of the shit. My job's done. You're safe for today. Let's wait for something else to show up again in 5 minutes ago. Okay. So this idea of SIM being this top layer of integrating all the security controls and everything really got to bugging me. This idea of, yeah, it's great at producing single point in time alerts, but it still couldn't get that holistic layer of what this actually means for humans. So I started throwing this together. All right. So as far as RDF and the like goes, subject, predicate, object. Really simple. Thing A, property, thing B. Gondor has hostname, XYZ, runs OS. This is the triples. Whole database is just a whole stack of triples like this. But for each of these things, hey, it's relational. I know what runs OS mean. I'm not sure exactly what SQL outer join hosts. Yeah, I'm not going to try and put a SQL query together right now. I'm too sober or too drunk. I'm not sure how it works, especially not with SQL. So you get this idea of ontologies where you define all these relationships, but they're not fixed. You can add new relationships over time. I can add new relationships to your data set. You can do to mine. We can traverse from one data set to another just with a single point of information. You give me one row, effectively, and I go, okay, I've got this row, a single node. But in that data is where all the relationships between other points, they're just traversal there. So everything ends up being this URI for both the relationships, the objects, the instances, the classes. There's no weird proprietary stuff to interact with it. And you can start putting together these wonderfully complex queries in natural language, because the actual schema is built out of natural language, not these weird outer join, cross foreign keys and everything else. So when you read my data and my data schema, it's like reading plain English. That's really cool, because I'm sick of having to teach new analysts SQL before they can be useful. But most of them I hire are pretty good at reading plain English. Amazing, really. So first thing we need, a whole bunch of ontologies. Every sort of possible relationship between things. IP address has octet, has netmask, is part of network. Vulnerability exists on software or software version that runs on OS platform. Exposure exposes this network segment to this network segment via this port or via this this attack class. And you can start developing all these wonderfully soft knowledge things that aren't really data. There's a lot of actual data in the system there, but then you're tying it all together with natural language that other people can look at and read. So this is not on slides, but I'm going to come back and give you one of my favorite examples. And how much time do I have here? Do I have time for a side story? Man, I better make this quick. Oh, goddamn, I'm going to be totally making you all aggro for run too long. So really quickly, we had a deal where there was something that looked a little out of place, an office in Germany that was going to be closed down in a little while. And it just so happened at the same time there was an office opening in Turkey. And on the surface of it, it didn't look too suspicious. But then I just sort of said, you know what? Germans really hate the Turks. Let's look at this actually, because it may just be some dude who's kind of really pissed off they're moving the office to Turkey. And kind of looked at it and, well, actually there probably was something more to it. But they came around and went, how did you know that? I'm like, well, I'm European. I know that Germans, well, Turks are the Mexicans of Germany because I'm European. And all the Americans went, wow, we would never figure that out with that. I'm like, you're right, but that's not really great amount of skill to put together. If you'd been looking at the stuff and it just said, oh yeah, office in Germany, office in Turkey. Oh look, there's this fact that links these two together. So I'm just going to present that up when you're looking at this. And just Germans dislike Turkish people. Link, oh look, there's something that connects these two things. Context, that's amazing. And any kid green off the street on his first security job doing incident response could go, there's probably something there. I'm sitting there going, I don't want to explain that to anyone ever again, but it would be really great to make it available. And that's kind of where this started getting into it. So back to this. So the framework is a whole bunch of ontologies. They're not static. Thing about ontologies, they're never complete. They're always designed to be iterated out. This is the first thing I'm really going to publish. I've got a couple of people I'm letting be an iron-handed dictator over a few things. But one of the major things about this framework is getting people to define new relationships they can see between bits of information and adding them to them. The great thing about semantic stuff is you can add as much of the stuff as you want, and it doesn't break anything. If no one uses it, no one uses it. If someone uses it and you don't, doesn't matter. It still works there. The flow set is basically about, this is about really building a security-minded data engine. where all the classes, all the data types are objects that are relevant to security. Hosts, users, exposures, vulnerabilities, exploits, threat surfaces, the whole thing. Whatever we can find out there that we can express in language, that we go, oh, look, this is something that someone else should know I want to record later because my memory is crap, we can put it into that, along with just straight out data sets. Oh, look, here's all my IP addresses, here's a bunch of reputation info. And they can coexist and be reused. So the flow set, the framework are just a bunch of simple code presented via HTTP REST. So that's most of my API. If you go, hey, what's the information on this host? There's a single unique URI for it. If you want to pull it out, XML, RPC, RDF, whatever. So the core server throws out all these particular ontology object types and just makes it really easy to manipulate them directly. Some command line tools, some GUI. Hopefully it's designed for mostly web apps and everything. Little standalone server. Great thing about semantic web, everything is a unique URI. You don't have to go out and learn SQL or anything else. So you end up iteratively building this database of information about the stuff you're working on, the stuff you know about, things you're bringing in from asset management or threat intel or whatever, and every single object is just, it's a unique URI. Someone goes, hey, what about that? Go look at this URI. I'll kick it out in plain text for you, or some fancy HTTP or whatever format you want, because I can do that because HTTP REST is pretty awesome. And I'm really kind of like skipping over most of the tech on this because it's not massively fascinating tech. It's all stuff that's out there. The last thing I wanted to do was try and reinvent the wheel on this. Just bring a bunch of things that are already out there and make them useful to InfoSec. So, yeah, still a bunch of conversions, import, export stuff and everything. We still have to populate things in from your IDS and Intel stuff, and that's a lot of the stuff that I'm hoping I'm going to get a fair amount of community involvement because they go, this main framework's kind of cool. I'd love to get this info in it. Maybe I should write a little script to do that. At least once I do that, I don't have to do it again. Some developer crap, some API crap. I'm getting short on time. I was hoping to have something more this week. I'm a lazy drunkard, so end of Q3. The main thing about this is that, yeah, I'm doing this for my employer, but when all's said and done, this is the last 10-odd years of me sitting there going, I really hate doing the boring parts of this job. Someone else should, like, figure out how to make this, like, suck less. And the last 3 years of going, I guess that's me. And then certainly the last year of, hey, I'm actually working for a company now that will let me do this, and other people can use it. Hooray. So if you guys like this, that would be like really kick-ass, because I've been like basically, betting the farm on this for forever. If you don't like it, I hope it's probably because more like you don't like me. A lot of people don't. But I'll probably cry. I'm hoping it's going to be awesome. This is all the stupid pain and crap I've seen with doing security work day to day for a paycheck. My attempt to like make something that makes it all easy, make a lot more sense. This is my big, community throwback project, and I'm kind of glad because I'm getting paid to do for it. So hopefully everyone wins. Alrighty, this is the app I'm kicking together with it. Everyone knows kill chain stuff. If you don't know kill chain stuff, you should do, because this is the first step to getting away from doing tech support alert after alert after alert. So the whole kill chain thing, developed by Lockheed Martin, and it's basically the idea that there's not one signature to one attack. Real attacks happen over multiple stages. Find the real attack in this crap, you can't. It's like blind men finding the elephant, and there are multiple elephants. We just can't do anything with this that's not without a great amount of experience and deep, dark work. This is not something you can really sort of put in front of someone and go, ha, yes, I can see the grand picture. And that's really one of the things that's murdering us on the defensive side. Just going through this rote work that doesn't produce real results. Because, 6 months later, lose all your source code. You know, that stat about like how most organizations have evidence of the breach in their logs? Yeah. What they really mean is they had evidence of the breach in their incident management system, where some guy looked at it and went,
I don't know what this looks like a fault. IDS is too noisy. Close, move to the next. Okay. But once you start like relating things together, it's a lot easier for even people without a great amount of experience to go, I can kind of see something bad happening here. So instead of going for this tech support model, I started going, you know what? There's a lot of better models out there, like QA, and police work, like evidence files. That's kind of an amazing thought. Hey, you know, we actually start keeping a file on people. What have you done before? Those 50 times you've been browsing ESPN from a server in the data center, like maybe that might be important to the stuff I'm looking at. You know, it's like, hey, I might actually be able to figure out, gee, I wonder how that machine got pwned. So once you start gathering stuff together and putting the big picture in front of people, people get a lot better at seeing the big picture. And then if you start actually bringing back the work they did on things before in context, so that when I'm looking at this host, I can actually see all the stuff that's ever been done on anyone else's. Like, hey, maybe I know what this one might be about. If you're recording all your knowledge in a ticket system and no one ever looks at a ticket again, got problems. Great pattern recognition engines. This is all like straightforward data, but once you start exposing the relationships between things, putting them in front of people, it's a lot easier to do better work with a lot less experience. Putting the dots together. And that's really the kind of thing here, is just making the talent scale down to a larger security audience, so that when I go, oh, look, hey, this thing, it's available to someone else later. They don't have to go sitting there searching through tickets. They run into another incident that has that same host, but because that host is in the same one, the notes are attached to the host, not the ticket. Objects are objects, things not strings. And go, oh, look, someone else found out what the system is for me already 6 months ago. Oh, it was me. Yeah, my memory's kind of bad. Because right now, you really got to find a single obsession to kind of drive you to do something worthwhile. This is mine. Because that thing on the left is what most of the stuff we end up looking at every day looks like. And, yeah. Then we go and do a whole bunch of manual info gathering to figure out what the hell that means. Incident response system I'm working on right now, really simple, without giving you a whole bunch of screenshots and everything, because I can't. That's what I want, is like, tell me what's actually happening. Brief me. I don't want to be a data monkey anymore. I want to be a secret agent going out and Jack Barrowing it down and going, yes, you, I got you now. Ha fair cop. Be a lot more fun than a lot of what it ends up with today. All right, folks, go eat and shit.
I was going to say at the start of this, if it's a good presentation, it will leave you with more questions than answers. If it's a bad presentation, it will leave you with more questions than answers. This is me trying to narrow down about 4 hours of crap into like 45 minutes of at least it was entertaining. Come harass me for shit whenever, and definitely. I'm absolutely all about talking about the shit more.
Before you run off, do you pre-register